Um, I'm the Dean of Engineering. I've been here for 3 years. It's a real pleasure to introduce Bill Mazotti. He's one of our alums, and he attended San Jose State University, and he earned his undergraduate degree in chemical engineering, which is exciting to me because he and I are both chemical engineers by training. And then while attending San Jose State, Bill was president of our local chapter of the American Institute of Chemical Engineers. He then went to Santa Clara University, just down the road or up the road, to earn his master's degree in engineering management and electrical engineering. He spent a long time, 27 years, in one of the biggest companies in Silicon Valley, National Semiconductor, in a variety of roles with increasing responsibilities. So during his work there, he went from process and product engineering to being a senior engineering manager for yield and characterization tools. And then he took on director roles in CAD support, optical transceiver research and development, and then finally director of the product lines for National Semi's interface products and solar energy. In 2012, Mr. Mazotti made the move to Altera's R&D leadership by becoming its vice president of worldwide packaging research, followed by VP of worldwide packaging and supply chain, and then finally as VP of worldwide quality and reliability. During his time there, he also served as executive sponsor for Altera's Society of Women Engineers. He moved to Isola Group as its SVP, Senior Vice President of R&D Operations and Strategic Programs in 2016, and then went on to become the company's Chief Operating Officer and Chief Development Officer for nearly 3 years before moving on to his current consulting work, which hopefully gets him a lot more flexibility back on his schedule. So with that, I'll turn it over to Bill to begin his presentation.
Okay, thank you very much for that introduction. I would also like to thank the Davidson College of Engineering and Dr. Ehrman for this opportunity. I sincerely hope everyone is doing well in these extremely challenging times. I have a tremendous amount of empathy for the students and for the faculty, as I have 2 sons that are currently in college, one at UC Davis and one at the University of Colorado in Boulder. So I can see firsthand that the challenges of remote learning and working on projects with remote team members and communicating with professors who are also remote. And I know it can be frustrating for the students. And I say that somewhat tongue-in-cheek in that I had to have my sons come back home, which interrupted the empty nesting situation that I had with my wife. And but now they're moving back to the universities, and I know that was frustrating for them to come home. And you know, from my standpoint, my wife's standpoint, it was great to have them, but it's also great to have them back at the at their universities. I'm certain that when we all get through this into what's going to be a great and exciting new normal, that we'll be better athletes, metaphorically speaking. So hang in there, everyone. So I'm going to talk about R&D. I'm going to talk a little bit about some philosophical and learnings that I've had working in research and development. And then I'll bring up a presentation where I will share with you some case studies that will demonstrate certain factors of success that I've learned throughout my career. So let's get going. Let me talk first about working within a research and development organization. It can be very rewarding in a unique way. From conceptualizing a solution that solves a critical or complex problem to taking that concept and defining a product, working with marketing, working with customers, and then taking that definition and building prototypes and eventually getting that product into manufacturing and ultimately into the market and seeing the adoption within the market and enjoying the financial returns. It's an incredible feeling coming from a research and development perspective. However, not all products developed and released into the market are successful. In fact, most products that are released into the market fail. Several years ago, I I participated in a study on analog semiconductor product success, working with National Semiconductor and ADI, Linear Technology, and Maxim. And what we found was that 75% of all new products in this space failed to achieve 50% of the business case commitments. That was quite eye-opening for us that participated in that survey. A more recent study out of Harvard, led by Clayton Christensen just 2 years ago, cited a 90% failure rate on over 30,000 new products released into the market. Typical reasons for product failure include being late to the market, manufacturing cost overruns, over-engineering, under-engineering, and loss of a critical strategic or flagship customer. These are symptoms of product failure. Based on my experience, they are not true root cause of product failure. Because change happens. Products can take years to develop and release into the market. We lay the groundwork with detailed plans, excruciating detail, line item by line item in schedules and business cases to give confidence to those that will fund the product that we will be successful. But it's our inability to manage the uncertainty and course correct when change happens, because change happens, that underpins the true root cause of product failure. 2,500 years ago, it was the Greek philosopher Heraclitus who said, the only constant in life is change. And then over 150 years ago, it was Darwin who informed the world that it's not the strongest that survives or the most intelligent, it's the ones who can best adapt to change. And over 30 years ago, the late Jack Welch, former CEO of General Electric and recognized in the industry as a leader of corporate transformation, stated, change before you have to. But change is hard. And anyone who's stepped up to lead change has recognized that you will have few supporters in creating sustainable change until that change is well on the way. And then everybody wants to jump on the bandwagon. Innovation and R&D are two sides of the same coin and synonymous with change. You can't create something new unless you invoke change. And not just exclusive to technology and product development. I've been fortunate to have led incubation projects, research organizations, business units in factories. Innovation and R&D is critical in human resources, in organization development, in finance, in legal, in information technology, and at a personal level. The phrase reinventing oneself, for example, changing yourself because of certain health reasons. It's hard. It's very difficult. Most of us don't deal with uncertainty and change very well. It's not in our conditioned DNA, so to speak. When we're young, we're taught certain beliefs and certain biases, right? And we're also taught that the world is somewhat predictable. You can't have your dessert until you finish your broccoli, for example. You can't watch TV until you finish your homework and brush your teeth before you go to bed. Step 1, step 2, step 3. And as working adults, we don't wake up in the morning and tell ourselves, self, I can't wait to see what's going to go wrong today. Or self, I can't wait to get to work and look at my project and think about all the things that could possibly go wrong over the next 6 to 12 months. But in order to innovate and to execute successfully, we need to anticipate the unforeseen. We need to manage the uncertain. We need to understand what our options are in innovation and how we would course correct when change happens, because change happens. We don't teach execution processes. We don't teach how to deal with uncertainty, but corporations expect flawless execution, and they embed innovation into their corporate values. And yet, as we've seen, the failure rate is exceedingly high on getting new products into the market. And so I've internalized this over my long career, working in a variety of functions, as Dr. Ehrman cited. And I've come to a framework that I believe and that I've employed leads to a much higher probability of product success. 4 factors that, if managed proactively, will lead to a much higher rate of product introduction success. And so I'd like to begin with the end in mind and share with you the conclusion of my presentation, and then we will get into the case studies. So let me share my screen. Give me a second here as I step up to my camera. And if somebody can confirm that.
Yes, we can see it.
Okay, great, beautiful. Okay, let me just close. I don't want to look at myself, so I'm going to close that. Okay, so this is really my perspective on innovation and R&D based on my experience working across several companies in a variety of roles. So here's your takeaway, and you won't hurt my feelings if you leave the Zoom session after the takeaway, but you will miss the case studies that are measured against these critical uncertainty factors. The first is that innovation and R&D absolutely has to be directed at a very clear value proposition. What problem are we trying to solve? And can we quantify that problem? And in an elevator from floor 1 to floor 4, let's say if you're with a key decision maker, can you articulate very crisply and clearly that value proposition? And has that value proposition been created in a vacuum by one individual, or has it been vetted with others that may have unique and complementary skill sets and may even have opposing values? It's absolutely imperative that value propositions have a broad 360 view of the solution and of the problem that is being the proposition is trying to solve. So that's number 1. And also, as we go through these uncertainty factors, they're not one-time development activities. So the value proposition would be reviewed on a regular basis as the product goes from idea phase all the way through market release. And if for whatever reason the key portions of the value proposition become invalid, then certainly critical action must be taken to either put the program on hold or revisit different opportunities for the value proposition or kill the program. And it's really hard to kill programs. Once programs get funded, it's like a train leaving the station, and it's not stopping until it's into the market. And that's a challenge for product development, and one of the main reasons why product success is as low as it is. So value proposition, very, very important to have a clear value proposition in place. The second is to have adaptive and multiple innovation strategies, not putting all of your eggs in one basket. And I will share with you a case study where this did happen, and it was a disaster. The analogy I like to use is a team that is tasked to climb to the top of a mountain in which they had no experience climbing previously. Would the team leader send the entire team on one route, or would the team leader separate the team into 3 groups and have them take different routes, because it doesn't matter who gets to the top of the mountain. The entire team doesn't have to get to the top of the mountain. One member is a success for the entire team. So having strategies that you can adapt based on changes in the market or changes in the product as it's developed, or having multiple innovation strategies from the get-go, is a clear approach, successful approach based on my experience to address uncertainty when change happens. And then the third piece here is process. What are the procedures that we will employ in idea generation, in innovation, in research and development, all the way through execution? Not processes or processes that administer a program, that report out the status of schedules or the risks and what we're going to do about the risks and the timeline and the critical path. No, processes that actually drive execution. And here's a place where companies, all the companies that Dr. Ehrman mentioned that I work for, could have done much better at, including the big companies out there. We take it for granted that companies know what they're doing. And I think also educational institutions can help here as well. And I'll talk about that at the end of my presentation. And then the last piece here is mindset of cross-functional team building, designing teams for success, looking at, honestly, looking at social styles, interpersonal skills, making sure that the team is built to operate at a high-performing level, and ensure that the team is making decisions based on data. When you're in research, variability is your friend, right? That's why we do design of experiments, for example. But if you're in research and you're not thinking about how the product is going to be produced in manufacturing, that's going to be a challenge, because variability is your enemy in manufacturing. Process capability is your friend in manufacturing. So these four areas: value proposition, multiple or adaptive innovation strategies, processes that drive, not impede or not bring bureaucracy, but actually drive successful execution, and then the mindset of the team and how the team is structured. So I took those four factors and I added information, because information is critical. And frankly, if the four factors that I mentioned and that are shown here as well are managed proactively and comprehensively, information will be part of those activities. It'll come in within the value proposition and the development process. But I thought it was important to add that one on the what I'm calling here a grading criteria. And this criteria, what I'm going to share with you is I'm going to go over 5 case studies across 3 companies, and we're going to use this as the litmus test or the scorecard for what went well and what could have been done better. Okay, before we go there, I want to talk about process. So the 2 most common processes in product development are stage gate for hardware and agile for software. And what I'm showing here is just an example of a stage gate process. Very typical. We had this at National, and then when Texas Instruments acquired National, we had their process, and we had a process similar to this at Intel when Intel acquired Altera. But frankly, when I was at Altera, when I joined Altera, they didn't have a process like this, and neither did Isola. So just to describe this process, on the left-hand side, you have what's called the ideal funnel. So you have a bunch of ideas that come in from customers, they come in from research, they come in from marketing, they can come in from a variety of areas. And they are tested. These ideas are tested against strategic fit, product roadmap, opportunity, business case, long-term revenue, long-term margins, and so forth. And ideas will then surface and be promoted into research. And once in research, you have lab trials, or if it's software, you have preliminary coding. You have a business case that's an opportunity of assessment and some pre-qualification type activities. And assuming everything goes well in research, The idea then is promoted into the development planning stage. And this is where all of the excruciating detail of planning occurs. Here I'm showing one, this is for a varnish system in a chemical engineering company. So formulation or hardware in the case of electronics, or software in the case of software development. You lock down the approach. You don't have to finalize the development, but you lock down the approach. The business case commitments come here, product requirements, manufacturing release, and very rarely do companies bring in manufacturing this early in the phase, which is another cause for why products take so long or fail when they are released. Supply chain qualification, et cetera. So this is all the detailed planning that goes into place to demonstrate you've done your homework and your due diligence when you go to the board of directors or the executive committee and ask for $100 million to fund your development. Assuming all goes well, the program is then promoted into development, and this is where all the fun happens, right? This is where we develop products, we do prototyping, we sample customers, we get reliability evaluations, we start the manufacturing release process, and then we move into manufacturing and release. And hopefully, if things are done well, and we've managed change, and we've had the foresight to look at uncertainty, we get to launch this product into the market and enjoy the revenues. But again, as you heard earlier, that's more of a rarity than a common occurrence. Agile is a different approach. Agile is used mostly within software where modules are developed completely from definition through software coding, through test and validation, and then the modules will come together and they build on each other over time. It's a very iterative process, the Agile approach is. And it's a great approach for software. It's tough to do that with hardware, but not impossible. And in fact, hardware companies that employ Agile type approaches where it makes sense succeed more often than not. And so there is a combination of both stage gate and Agile which works. And in fact, if you're interested, Preston Smith, who I know, wrote a book called Flexible Product Development. It's a great book. And it takes the Agile approach from software and applies it to hardware development. So a good read if you're interested. Now, the challenge here, of course, is that within any process, whether it's stage gate or Agile, you don't have just one product. You have a portfolio of products that are being developed concurrently and exist at varying stages within product development. So you might have some spins off of a previous product, or a derivative from a previous product, or a new platform, a completely new platform that had no pre-existing IP. So you have a spectrum, if you will, of different types of products, which absolutely necessitates some type of oversight, some type of process to ensure that we're keeping an eye on uncertainty, we're keeping an eye on the business, we're keeping an eye on resources that might be pooled across multiple projects. But at the same time, you have to manage process so that it doesn't become too bureaucratic. So complete innovation without process will yield what I would say anarchy, right? So you'll have people working on projects that have no process and that are not tied to the business, and there's no real rhyme or reason why they are working on that project. And then on the other hand, if you have too much process and not enough innovation, you end up with mediocrity. And so it's the balance between that anarchy and the mediocrity of product development, somewhere in between, that needs to be defined, and it's going to be different for the level of complexity of products. And so all that needs to be thought through as products are being defined and considered for product development. Okay, with all that as a backdrop, let's jump into the case studies. So the first case study I want to share with you is Solar Magic. Solar Magic came out of the University of Salerno in Italy, at least conceptually. The initial schematics was in research for 2 years and development for 3 years. It was the #1 program at National Semiconductor from 2007 until 2011. At that time, National was trying to move up the value chain and not just provide ICs, but provide subsystems that solved higher end type problems. Solar Magic is a subsystem. It's a DC to DC power optimizer. Okay, so what does that mean? It's a DC to DC power optimizer for photovoltaic installations that through a buck boost type technology exchanges voltage and current across a string of panels and across the array during situations of mismatch, such as shade, which would basically cause a bypass diode to kick in and you would lose potentially a third or all of a panel. Or bird droppings, for example, seriously, bird droppings on top of the photovoltaic cells. Or rabbits chewing on power lines on the photovoltaic system. The intent here was to have a subsystem that would maximize the power. And so within this subsystem, there were buck boost regulators, there was a maximum power point tracking controller, there were gallium nitride switching MOSFETs that would together provide that solution. And today, there are solutions like this on the market, DC to DC power optimizers that do exactly this, as was originated with this value proposition. There are also DC to AC inverters, microinverters. In fact, the solar installation that I have on my house in Gilroy has microinverters. So instead of having a big inverter on the side of my house, each panel has its own microinverter converting the DC to the AC. Great value proposition, right? Well, what happened? So after spending close to $200 million on this program, and this program being the most important program at the company, it failed. And it failed for several reasons. And I cite these reasons here in red. First of all, the program manager for Solar Magic was the CEO of the company. And that presented an exceedingly amount of overhead in terms of managing the program manager. And in addition to that, there was only one strategy. So when we think about innovation strategies and have multiple approaches, or even having an adaptive innovation strategy, it wasn't there. It was, you're going in this direction, move and get it done as quickly as possible. And as a result of that, down there on development processes, there were no processes that were employed. Even though the company had stage gate processes in place, this was a special program and we didn't need process. And let's move forward. On the value proposition, yes, the value proposition was clearly understood in 2007 when the idea of a power optimizer at $2 per kilowatt would be very attractive in the market. And at that time, back in 2007, panels were being developed out of Europe. And between 2007 and 2010, all that manufacturing went to China, and the value proposition of $2 per kilowatt fell by the wayside, and it was no longer cost effective. While other companies obviously recognized those challenges and modified their product to ensure that they could meet the decrease in dollars per kilowatt hour required for any components going into the market. So, great example of maybe too much sponsorship, ignoring market trends, and also not following what you had in place as tried and true processes. Now, in the end, we were able to salvage some of this program in terms of a reference design for others to follow, but I'm not certain that ever actually materialized to anything that is exciting from a revenue standpoint. Somewhat of a disappointment, and I was intimately involved with the program. In fact, I was the individual who every Monday had to go up to the principal's office, the CEO, and explain what was going on with product development. Okay, the next case study I want to share with you is 28 nanometer FPGA, which was in research for 1 year and in development for 6 years. At 40 nanometer, Altera owned the market. It's a duopoly in FPGAs between Altera and Xilinx, and Altera did a fantastic job at 40 nanometer and took market share away from the competitor. So what happened at 28 nanometer? Well, between 40 nanometer and 28 nanometer, the company lost a great deal of expertise through retirement. And not having any processes whatsoever, the processes that I've been talking about in place, all that tribal knowledge went out the door. In addition to that, between 28 nanometer and 40 nanometer, or excuse me, 40 nanometer and 28 nanometer, the company reorganized and created an IP group and an integration group. Whereas at 40 nanometer and at larger feature size FPGAs, the company was organized based on product family, where within a product family, you would have a team that would do the IP development and the integration. And I get it. You want IP development to be applied across multiple product families. But along with the loss of the tribal knowledge and the lack of processes in place and the reorganization of the company, 28 nanometer FPGA launch out of Altera took way too long, and the company lost a significant amount of market share to the competition. Okay. All right, let's move away from electronics and let's talk chemical engineering. So case study on Formulation X. I'm calling it Formulation X to protect the innocent, so to speak. This formulation was in research for half a year and then in development for 6 years. By the way, just to go back to the 28 nanometer FPGA, this program, the investment here was on the order of $500 million, so $500 million to be late to the market because of the changes that I described. Formulation X was probably on the order of $50 million in terms of the investment, and it had unbelievably significant challenges across the board. The value proposition was very clear. The company had been recognized for its history of being a technology leader, but it failed on this latest, greatest technology, a varnish system composed of internally synthesized resins with solvents applied onto printed circuit boards as a dielectric, and in this case, for high-speed signal integrity type environments such as backplanes and base stations and so forth. And what happened here was that the company wanted to get the product out too quickly, and the company had no processes in place, and the formulation was being driven by a hardware person, not even a physical organic chemist in the house. So there was a lot that went wrong here. The team was disparate. The executive leadership pretty much drove the team to not communicate with each other and tried to drive the decision making, not unlike Solar Magic, from the top of the company. And what ended up happening was the board of directors pretty much dismissed the entire leadership team, brought in new leadership, brought in a new CEO. I joined the company. Myself and the CEO and other new employees that came into the company at a leadership position immediately put in processes. So there was a clear role for the executive, a clear role for the team. We rebuilt the team to ensure that we had unique and complementary skill sets. We took a look at the innovation strategies. We put in place a physical organic chemist that I hired, you know, in the local area, and we looked at three areas of innovation. One was on equipment, of how the laminates were being produced and how the varnish was being mixed. The second area that we looked at were impurities. and impurities coming in from raw materials. And then the third area that we looked at was customer application, to ensure that as we addressed the formulation and through impurities and the equipment, and we modified the equipment and we modified the formulation and we found issues with impurities, we were able to recover a lot of the quality related issues that the company had suffered because of the premature release of Formulation X. Okay, back to electronics. This was a great program that I was part of when I was back at Altera. Generation 10, 20 nanometer lead-free FPGA. The value proposition here was to be the first completely lead-free FPGA family on the market, and we were successful. So we had an executive sponsor that encouraged competition, that encouraged multiple innovation strategies. So we looked at tin silver for the bump technology. We looked at 2 different types of copper bump technology. We pulled together TSMC, Amkor, and ASE, companies that normally wouldn't be working together, and with ASE and Amkor, competitors. We pulled them together to help them develop with us at Altera this value proposition. And I built the team, not taking credit for this, but we had a great set of, and clear set of unique and complementary skill sets. Everyone worked together towards a common goal of getting this first lead-free FPGA into the market. And yeah, there was competition. The tin silver guys believed in tin silver. The copper bump folks at TSMC, they wanted copper bump. And yeah, there was some contentious discussions. But in the end, it created the right environment. And everyone was able to succeed or be part of this program. Just a great win for the company, and even led further to additional joint development activities at Amkor, ASE, and TSMC, as they learned that, hey, we can actually work on developing technology with competitors, with suppliers, and with customers. And there was a press release that went out on this advanced packaging technology, which I was part of, and that was a lot of fun. Okay, my last case study, Optifider. This was probably the most enjoyable project that I was associated with in my career. And I've enjoyed a lot of projects within my career. So let me talk about what Optifider is. It was a program that was in research for 3 years, but never went to development. And so what Optifider is a alternative solution to small form factor pluggable optical transceivers. And at the time we were developing this technology, small form factor pluggable transceivers, if you took off the casing and looked inside, you'd see 70 or 50 discrete components: capacitors, resistors, memory, controllers, canned lasers, canned detectors, and so forth. Highly manual from an assembly standpoint, and yields were not all that great back at the time in terms of alignment of fiber with the pin diodes and the lasers and so forth. So the idea here was to take semiconductor manufacturing technology and see how much can we actually integrate on these mini PCBs that existed within a small form factor pluggable transceivers, optical transceivers. And so the image on the upper left there shows at the base, it shows a leadless chip carrier. I think it was a 24-pin transceiver, a bi-CMOS transceiver inside of the package, along with an EEPROM. And then on top of the chip package, through a solder ball uplink, we mounted a low temperature co-fired ceramic subassembly of 7 layers. And then on the face of that, we mounted a 1x4 array of VCSELs, vertical cavity surface emitting lasers, and a 1x4 array of pin diodes, along with the transimpedance amplifier to get the current back down into the package. This was an incredible program, a great accomplishment for a team that was effectively in a lab for 3 years working together. And we proved through acceptable bit error rate testing that we can transmit and receive 4 channels simultaneously. The team, many of the team members have went on to successful careers. In fact, the lead designer on the analog transceiver is now the CEO of Altera in Silicon Valley. They are basically a cloud-based silicon design startup, getting great funding. And I learned a great deal. And this is actually where I cut my teeth in packaging. So everything went well here. But even when everything goes well, that doesn't necessarily mean the product's going to be a success. So what happened with this program? Well, we completed this program in 2002. And for those of you who are old enough, you might remember back in 2002, we had the dot-com bubble burst. And this was an adjacent activity for National Semiconductor at the time. And to my disappointment, if you will, National decided to kill this activity. And the stock in the company at that time, and all companies, were cut by at least a fifth. I think National was at $100 at that time, and it dropped down to 20. And so the company, rightfully so, had to do things to ensure that they weren't that they were spending wisely. But I think what they could have done with this program, because it was way ahead of its time, is they could have slow rolled it, with a fraction of the team members, and then raise that back up to the level of full development once the market recovered. Okay, so back to the takeaway. Again, having a very clear value proposition is a must. And today, as I consult, I try to drive this message home. What problem are you trying to solve? Most often than not, when I consult or when in my career I would come into a new R&D organization or in a business, we have engineers and business folks working on a solution to a value proposition that isn't clearly understood. Having multiple approaches, not putting all of your eggs in one basket. It may seem to be, on the surface, a waste of time to take multiple approaches in terms of product development. And that's why it's important to have executive sponsorship to encourage multiple approaches to innovation. And then having the right processes in place. Again, at Altera, at Isola, there were no processes. And it's amazing how quickly, once processes are put in place, and of course there's a buy-in, right? Because you have a lot of old school folks, so to speak, that maybe, that non-admit-here mentality that may feel that they can do it without following a procedure. And it's just not the case. And processes not just drive successful execution, but they drive communication. And then having the right team members on the team. The adage that one bad apple can spoil the whole bunch is absolutely true. I've been involved with far too many projects where the team became dysfunctional because of one person. And the right approach for leaders is to do something else with that individual for the sake of the team and the success. Okay, so my last slide here, and then we'll open it up to questions. So opportunities to explore. So I thought about this, and having 2 sons in college, my 2 younger boys are still in school, and as I spent time with students in the chemical engineering and materials engineering department and reviewing resumes and just kind of talking about curriculum, and then as a hiring manager and thinking, okay, in addition to the core skills of engineering, what would I want to see from someone coming out of the universities that can help them hit the ground running right away? Yeah, okay, it's important to understand, how to run simulations or how to do formulation or how to do the analysis and so forth. But what additional to that will help us execute right away. And so I came up with this list. And again, this was just somewhat off the top of my head. And so again, broken down into the areas of value creation, drive and execution, innovation strategies, and mindset. So with value creation, so maybe with graduate students, we bring in concepts around how ideas are generated and how value propositions are created and how they get communicated, which brings in the concept of social styles, basic finance, P&L, and balance sheet awareness. And again, these are not, I'm not suggesting that these are courses. What I'm going to suggest is that somehow these tie into existing courses or existing projects. And then on the execution side of things, agile, if it's not currently being followed at the university, in software development, in stage gate, in terms of project management and hardware development, the concepts, bringing those concepts in. And I apologize if this is already being done. I just I don't see that. And it's just that there's a lot going on, right? And students need to get through a curriculum. And again, I'm suggesting that potentially there's an opportunity to fold in some of these ideas into existing curriculum. And then risk assessment. We do a horrible job at risk assessment in the industry. And I will say that from Intel to Isola to every company and every supplier that I've worked with. We do an absolute horrible job at failure mode and effect analysis for process, for design. We do a horrible job at designing for test or designing for manufacturability. And then even if we do that, we don't even put in the mitigation plans. We just acknowledge that we understand the risk. And then team building, making sure that we intentionally design teams for success so that one bad apple is maybe off doing something else that's important, but the team is designed with complementary skill sets with the right social styles and the right mindset, the right goal in mind, common goal, and that experimentation and statistical inference and problem solving are also incorporated. I am dismayed by the lack of statistical inference and formal problem solving that I've seen in my career and recently as in my career, throughout my entire career. And so these are things that potentially the university can explore. And so I just wanted to throw this out there to conclude my presentation. Hopefully you've enjoyed it. And last thing I want to say is thank you very much for this opportunity, and go Spartans.
All right, thanks so much, Bill. If we were in the room, there would be applause. So I'll applaud on behalf of our attendees. So we do want to open it up for questions. So if you've got questions, if you could either raise your hand, if you'd like to say the question yourself, or if you want to put the question in the chat, we can read it out to the group.
Oh, I have a question.
Did you raise your hand, Anand, or put it in the chat?
Okay, how do I?
Giving you some grief. Okay, well, we'll just say that you raised your hand and I'm calling on you.
Okay, all right. Sorry.
Yeah, no worries.
Oh, Bill, that was a great talk. I'm in chemical engineering, and thanks for sharing your thoughts. So the question I have for you is, this day and age when things are changing so rapidly, and not to mention COVID, how does one, either as a consultant or as an individual or as a company, make some of these decisions, and what is going to be, how do you assess what is valuable?
Yeah, that's a big question, right? And it comes down to leadership. I remember when I was convinced to go over to Isola and run R&D there, and the CEO talked me into making that move, and which started a 3-year career of me traveling 99% of the time, it seemed like. Actually it was. I demanded one thing from the CEO, and that was to mandate transparency and formal project management, which encompassed the uncertainty elements And so immediately, teams that had been working in isolation or in a vacuum were called upon to present in a very transparent way what they were doing. So it really comes down from the top. If employees are convinced that this is important for the CEO and the leadership team, they will follow suit. And within the formal project management and the transparency of reporting out to the executives on a regular basis comes all the things that I talked about and answers some of the questions that you raised.
Thank you.
Yeah, so I have a question while we wait for, hopefully we can get some student questions too. When it comes to team building, you talked about the bad apple, but what are the characteristics that constitute good team members?
Great question. I love that question. And I would refer anyone who's interested in successful team composition, I guess, to read Patrick Lencioni's book called The Ideal Team Player, because it clearly articulates in a very wonderful way through I wouldn't say a fable, it's kind of written like as a novel, what constitutes an ideal team player. And in the book, and I'll answer your question in a second here, in the book there's also interview questions that you can use to test individuals. I don't know if that's appropriate to say, but to use during interviews. So it comes down to being hungry. 3 areas. 1, being hungry. So you want a sense of a team player that is not on their heels, but they are leaning forward into the problem. The second area, which I think is a huge factor in team dynamics, is humility. And being humble that you don't have all the answers, and that you're going to work together and you're going to learn, and you're going to accept the fact that you might be wrong, which typically the bad apples won't. And then the third area is being smart, and not necessarily smart in terms of intelligence, but smart in how you communicate. So you might have a social style that's very driver-oriented. You don't want me to ask you how your weekend was. I might be an expressive, and I want to have these discussions. Being smart enough to know how you communicate to different team members, and also how you communicate to leadership as well. And so I would say it really kind of comes in together with those 3 areas. And I read the book a long time ago and immediately started looking at my team in that light, or in that lens.
All right, thanks, Bill. All right, questions from students. Questions from hungry students. Got quiet students today. So maybe let me ask another question then. So you talked about what you were looking for when students were fresh out of school. What is the difference in what you look for when somebody's an entry-level graduate and looking for their first position versus what you might look for with somebody with more experience, where school is kind of like a little bit of a hazy memory, and accomplishments there on a university campus are not as much of a big deal because you've got other things to stand on to bring to your application and interview?
Right. For another good question. So for graduate students, and I tell my boys this as well, and I coach them and I coach others, is your coursework is important, of course. Your grades are important, of course, especially for new graduates. But there are more things that are important as well. What clubs are you involved in? How are you contributing to your community? What hobbies you might have? What do you like to do outside of work? I look at much more than just the coursework. When a real quick story, when I graduated from San Jose State and started working at National Semiconductor, I was put into a team with chemical engineering graduates from MIT, Stanford, and RPI and a few other universities. And honestly, I was a bit intimidated. But I think there's a lot more than just what school you go to and what courses you've taken. And so, again, the short answer is for the new graduates, it's more along the lines of what else are you doing besides your curriculum? And can you articulate that? And I do a lot of resume reviews, and I provide a lot of feedback in that regard, among other areas. Now, for more experienced hires, I look at where they've worked, and if I see a resume where somebody's jumped around 5 different jobs or 5 different companies in 5 years, that's hard for me to. That's a challenge for me. And so, and I do talk with students that have graduated from San Jose State over the last couple of years, and they've landed a role, and now they're asking me that, hey, Bill, I want to move on now. And when you're just out of school, I think it's important to find some stability, and at least for a few years. So for the more experienced, I look at the resume in terms of whether they've been jumping around, and then I look at various accomplishments. I look at and see whether or not they've quantified, and can they communicate the quantification of their accomplishments. And do they say, hey, I was responsible for this team and we developed this product? Or do they say, I drove this team and we were able to cut development cycle time down by 30%. And then I'm also a big fan of references. So if someone makes it past, my first round, I will likely reach out to references as well.
All right, great. This is really helpful. All right, I know it's 1 o'clock. Students may need to get off to get to their next class, but do we have any other questions from students? Everybody's so quiet.
It's okay.
That's like my class.
Oh, okay. Yeah, this is one of the frustrating things because the mode of communication is just so different. We'd be in an auditorium and people would be raising their hands and all of that, and we'd be running around with a microphone. So I'm getting a lot less exercise, that's for sure.
Well, invite me back when you're back on campus.
Yeah, so we can definitely do that. All right, so one more time, any questions from students? Happy to. I know there's people on the Zoom that have asked questions before in different settings. I know who you are. I've seen you. You're welcome to ask again. All right, well, I'm not seeing any, so why don't we give you a virtual hand again, and we're going to take you up on that offer to have you come back. And I'll share out the Go Spartans from Olga. Awesome. And we're getting some thank yous coming through the chat. We appreciate it. And for students, we really appreciate your time. Keep in mind, we've got, I think, 5 more of these this semester. And then we also have the Dean's Career Conversations, which is a smaller group. And we have mostly alum at that one. We do have some people that are non-alum that are just some connections through me or through some other of the faculty members. So I hope to see you at future events. Thank you very much.
Thanks, Bill.